Just one comment about the 6 homework graphs. Cotangent, the very last one. Sometimes there's some uncertainty about that point in the middle, the x-intercept. It could be that you got on your calculator that it was undefined. It turns out, though, that that's one of those technicalities that it actually is defined. But you're typing in your calculator 1 over tangent, and you might remember that there was one day we did a problem like that, where technically you actually can do the cotangent of 90 and of 270. So the bottom line is the graph connects. Your cotangent graph connects in that middle point. Okay, and I didn't take any points off on your paper. I more just want to tell you. Okay, you don't kind of end up with this like sort of this extra asymptote. Okay, you only have the asymptotes at like the edges of the cotangent graph. Okay, so you don't have an asymptote again at 90. Okay, and you end up seeing that today or tonight when you end up doing cotangent as a homework graph. Okay, now part of our goal today is to start to identify and kind of figure out these answers for our graphs. Part of our goal today is just to graph these things on our calculator and just to start to get to know the graphs a little more. There might be some parts of this that you want to play along. Like, don't just watch me do it. You're going to want to, on your calculator, kind of push the buttons and get some things, start to notice some of these things. Sometimes students will begin to wonder, do I have to memorize this? It has such a negative connotation, memorize. But I'll be honest, as we go through this chapter, you will get to know these items from memory. So just a little different way to say it, you're going to get to know these things. Yes, eventually you'll have them memorized. Now, we're going to do the sine wave. Okay, we're going to do y equals the sine of x. What I mean by that is we're going to do it on the calculator, and we're going to come up with some of this information. So, depending on your kind of past experience with the calculator, you want to go to the y equals screen. Actually, I'll tell you what, before you go to the y equals screen, make sure your calculator is in degree mode. Especially if you're borrowing a calculator, make sure it's in degree mode. The mode button is near the very top left. And almost everything we do in this chapter, you want to be in degrees. Okay, now once you're in degree mode, you can push the y equals button, which is in the very top left corner, and pretty much type in y equals the sine of x. Now, normally what you would do is you would push the graph button, but we're graphing a trig function. And so the calculator has a special window or zoom set up for a trig function. Okay, it's called zoom trig. Now I hit the zoom button, top middle, and I'm scrolling down to number 7, which is zoom trig. What this does is it kind of resets the window to match degrees. Kind of like yesterday when you graph stuff by hand, you needed a special window. You needed to go by 30 degrees. Okay, so I hit zoom trig, and that gave me that special window. Now, some of you with like a newer calculator, that TI 84 plus CE, you might see more graph than what you're seeing up here. Some of you guys with a newer version, it's showing more sine wave. But you'll get to know it. Okay, now in your notes, you're going to want to have a sketch of this. And I'll be honest with you, you're actually sketching the same thing that you graphed yesterday, but it doesn't hurt to draw it again. It helps you to start to get to know the sine wave. And it allows me to mention some things to you, like where does it start? Now it starts at the y-intercept of 0, 0. And that's going to be a point that you're going to want to note. Okay, now it also ends. When I say ends, I'm talking about one period, which we'll continue to discuss, but it ends at 360, 0. Okay, and you just want to start to notice some of these points. Now, in the middle, we have the point 180, 0. And again, it's just an important point to kind of label and to notice. Now, you're probably copying it off the board for me. That's fine. That's what I'm here to try to help you learn this. But I want you to play on your calculator and realize that you can see the same things. I hit the trace button and kind of get this little blinking spider that traces these points. And so, for example, I could trace over to the point 180. Don't be scared to play along. I could trace over to the point 360. Go ahead, Brandon.
I cannot get it to make a graph like that. Like with the zoom and the trace, it just like ends up being a flat line.
You've got some extra stuff turned on here. Go ahead and just type in the sign of X right there. Make sure you hit zoom trig. Any other calculator concerns? It's normal to have some problems, okay? But you'll work them out. Again, you're tracing the graph. You're just kind of noticing some of these points. Now, you also want to sketch the graph, and just taking your pencil and drawing the sine wave helps you to get to know it. It helps you to get to know it. Now, that's the same graph that you created yesterday. Not quite as detailed. You'll notice that I only drew that portion of the graph. That's known as one period. And it's honestly sort of the most popular period, okay, because it's the positive period. Now, you could go backwards. The calculator shows that. You could go backwards. I'm kind of just making it a dotted line because I don't want to overemphasize it, but the sine wave would continue to repeat itself back that way. Okay, now I use this word period a few times, but let's do this in order. Let's talk about the amplitude, and then we'll talk about the period. And again, these are just some like factual things. These are just like answers that we're going to reveal, and it'll be the same answer next time. Now, the amplitude is this idea of the distance from the midline. Okay, maybe the midline is something that we should notice being the x-axis. And again, you'll get to know this. But if you look at the distance from the midline up to a maximum or a minimum, you can see that that distance denoted by those yellow arrows is 1. That distance is 1. And that's why the amplitude is 1. Okay, I'll just spell it out to kind of emphasize a little more. Okay, but again, it's that distance. Now, the period is going to be a pretty popular idea. One of the main things we do in trigonometry. And again, I've said a few times, it's the distance to see one cycle. And that's what was highlighted from 0 to 360. If you look at my finger, I'm going 0 to 360, and I'm tracing over one period. That means the period of this problem is 360 degrees. I want you to notice that it's an x number. It's an x number because it's always an angle. It's always an angle. Now, after you go through one period, the graph would repeat itself. And some of you, your calculator shows you that. Some of you, if you just trace a little further, you'll see that the sine wave continues to do the same thing. Okay, and so that's why in 360 degrees, we see, again, one cycle. Domain and range. Not always everybody's favorite idea, but it's just kind of one of those things that we talk about in math because it describes the kinds of numbers on the graph. Now, the domain is the x numbers, and if this graph is going to continue to go up and down and cycle back and forth, it'll do that forever, meaning that any angle, all real numbers, are going to work for the domain. Again, The domain is like the x values. And because this graph goes on forever, every x value will eventually be part of the domain. The range is a different story. You should feel like that the y values of this graph, are between two numbers. Okay, so they're between y equals 1 and y equals -1. So we can say that the range is -1 to 1 using some bracket notation to say that we can equal -1 and 1. I want to show you something to basically say that this graph isn't just because. It's not just because that's what your calculator showed you. It's not just because that's what it looked like yesterday. It actually is because of the unit circle. Now what you're going to see here is y values on the unit circle. And those y values are denoted by that red vertical line. Now, the y value, again, on the unit circle, is actually being graphed. It's actually being graphed on the x and y axis. Okay, so right now, this y value right here is the same as the y value that's being graphed here. Let me put it in motion again so you can see that as you go around the circle, you get different y values. Also get a little music. Okay, now are you thinking? I mean, it's something you just kind of have to be thinking, but the y value right now on the unit circle is 0. The y value is 0. Look what you graphed over here. 0. A y value of 0. Okay, every y value as I went around here was graphed as a y value on the x and y axis. Now look at the y values. They're negative y values on the unit circle. That's why we have a negative graph. And then it just goes backwards, which is kind of weird. You're like ungraphing it. Okay, so it's a little mathy, but it's good math. Okay, the graphs that we're creating ultimately go back to the beloved. Let's do another one. Okay, just so you know what's going to happen here is I'm trying to help you understand how to look at a graph and see this stuff. Eventually, you're going to look at a graph and try to see it. You're going to look at it with some homework problems. You're also going to look at it with a little practice problem here. Oh, you know what? Forgive me. I think that it'll work for you, but if you want to kind of put this in the same order as kind of like what you did yesterday, probably this is going to be cosine. But it's going to be your homework problem. It's going to be your homework problem. So what I'm saying is maybe make a space. Make a space for the same thing that we just did. Now, let's talk about tangent. Just trying to help you kind of get your notes organized. Let's talk about tangent together. Now, tangent kind of marches to its own beat. I hope you saw that yesterday. When you graphed it by hand, you got some different kind of behavior, right? You got those asymptotes. You also got a graph that kind of went up and down to infinity and negative infinity. A couple things about your calculator. Try to get to know it. If you hit Zoom Trig, like 5 minutes ago, it's still in Zoom Trig. But if you kind of like want to reset it just to be sure, you can always hit Zoom Trig again By the way, you can type the number 7. You don't have to scroll down to 7. You can just type the number 7. See if it works. You're trying to graph tangent. Now, it's the same graph you saw yesterday, but you're getting a little bit more. You're getting more period. You're getting more of the waves. Now, just sketching it is one way to get to know it. And you want to have a little sketch of the tangent wave. You'll notice that I only sketch the one, quote, in the middle. Kind of sketch the first one. Now, on the TI calculator, are you realizing that these little hash marks, and I'm putting in red, they go by 90 degrees. It's helpful to know that. Okay, those little hash marks go by 90 degrees. And a little bit just because we saw it yesterday, and a little bit because I'm telling you today, there's asymptotes. Don't draw on your calculator. I guess if it's yours, you can do what you want, but don't draw on mine. But on your notes, make sure that you show these asymptotes. Now, asymptotes are identified with dashed lines, but we also label them. We label them with their value. And so to say x equals 90 or just 90 is going to be part of a tangent sketch as we go through this chapter. Again, you want to label those asymptotes. By the way, this x-intercept is a good point to label. It's pretty easy to see that it's at 00. Now, it should kind of cross your mind, like asking, well, how do I know for sure the asymptote's at negative 90 and 90? I mean, we saw it yesterday. You kind of said it today. Trace to the asymptote. But be careful, because remember, if you go to an asymptote, you might get burned. But the calculator can handle it, because if you try to trace to the right, now you're tracing to the right, but it looks like the little cursor is going up. Nonetheless, you can trace to 90, and I just want you to observe that there's no y value. Okay, that's a little bit of a sign that there's an asymptote. I say it's a little bit of a sign because it could be something else that you'll keep learning this year, but if the y value disappears, okay, it's undefined. And that's a kind of a way that we can say, okay, there's an asymptote there. Now, if I keep tracing, I can get to the next wave, the next period. I can also get to the next asymptote. And it wouldn't be a bad idea to add that to your sketch, just so you realize that the graph is going to keep repeating itself in the next cycle. I also want you to start to notice how these numbers are spaced. Even this x-intercept is a certain distance from the first one. It would be 180. And so we want to start to see that in 180 degrees, we're able to see one cycle of the tangent graph. Do you see what I'm alluding to here? 180 degrees. That would be the period. There is no amplitude for a tangent graph. It has no max or min. So we don't talk about the period. We don't talk about the amplitude, but it does have a period of 180. Okay, so in 180 degrees, the graph will start to repeat. How about the domain? I will kind of say to you that even though maybe this isn't the most interesting thing ever, there are some other things that are more fun than this, but I will tell you that the domain for tangent It might be like one of the main thinking parts today. Okay, like it might be something you're like, whoa, what was that again? So let's talk about it. You're going to get a chance to try it again. The domain is supposed to be like the x values. Okay, the x values that are part of the graph. But sometimes what we do is we think sometimes what we do when we talk about the x values is we actually focus on the x values that you can't use. Now, there's some x values along here that we can't use. It's these darn asymptotes. So you want to kind of focus on them with me. Because the domain, in one sense, can be all x values such that you're not allowed to equal the asymptotes. Now take a look at the notation I'm presenting to you here. It's called set builder notation. Again, I wrote the letter x, and then I put a vertical line. That stands for such that. So all x such that x cannot equal the asymptotes. Okay, now what that's saying is that the domain can be every other x value. The domain can be every other x value except negative 90, 90, 270. Okay, but that's a little bit of the JV answer. Now, it's not bad to make the JV team. It's the starting point, but we want to be on the varsity team. And what I want to do is give you a more proper way to describe this domain. In other words, as a formula. Okay, now as a formula, what I need to do is think a little bit about the kinds of numbers that I'm not equaling. The kinds of numbers that I'm not equaling. Again, negative 90, 90, 270. First off, those numbers are always spaced 180 degrees apart. Okay, since those numbers are spaced 180 degrees apart, they will be in a multiple of 180. Go with me for a second. They will be in a multiple of 180. Now, what I just wrote here is 180k. Sometimes people are like, what? What is that? Okay, well, k stands for any integer. Okay, like 1, 2, 3. So what this is saying is that my asymptotes can be any multiple of 180, any amount of 180s, shifted based on my first asymptote. Now I'm pointing at this number here because my first asymptote is at plus 90, and so I need to shift this formula by that value, by a plus 90. $180k plus 90. 180k plus 90. What the heck is that? It's a formula where you can plug in your favorite integer. What's your favorite integer? 1, because you're number 1. If you plug in 1 to that formula, look what pops out. The position of an asymptote. What's your next favorite integer? 0. Sometimes you feel like a 0. If I plug in 0, out pops an asymptote. Now, are you catching on to kind of why this formula works? You can plug in any integer. Even though we're unlikely going to travel to 990, there's an asymptote at 990. Because all the asymptotes are in a multiple of 180 shifted by 90. Now listen, as you go through this lesson with me, there should be some times where you're like, is it always like this? Well, yeah. Next time you graph tangent, this is going to be the domain. Okay, what you're going to find out shortly is we're going to start to change these graphs. We mean change them. We got to come back tomorrow. But if I start to change this graph, then the asymptotes change. And if the asymptotes change, then I have to modify this formula. But to understand this formula on today's lesson, 180 is the distance between, this is the distance between, okay, and 90, I called it the first asymptote. Now, the first asymptote can be put in quotes because technically the first asymptote can be whatever you want it to be, but normally we just pick the first positive. So 180 is the distance between the asymptotes, and then 90 is the first asymptote. And that'll help you to be able to modify this formula for the next problem, which is what let's do the range of this thing. And then I'm going to give you guys the next problem. The range is the y values. If I was going to walk along this graph, I would touch a lot of y values. In fact, I'd be able to touch the y values up to infinity. I would also be able to touch the y values down to negative infinity. The graph goes up and down forever. Okay, so the range has no restriction. The range has no restriction, all real numbers. It's the domain that you kind of focus on. Now, in your notes, you have sine, maybe cosine, did you leave a space for it? And tangent. What I want you to do now is try to analyze cosecant, which would have been the next one that you did yesterday on the back of your paper. But I want you to kind of analyze cosecant. That means a couple things. It means that you're just going to try to graph it. You're going to try to draw a sketch. And then as you get deeper into it, you're going to start to notice some of the numbers. But instead of, watching me, I just want to give you a chance to try it. Can you start to analyze for these numbers, for these ideas?
Just kind of give some time to play around. How's it going? I'm not like a passive expert. They do work. I have students using them, they really love them. So it's going to be, so it's not producing the crowd. Yeah. From a scheme program, like trying to learn a lot more. Once you figure that out, I encourage you not to give up. But I just can't tell you, hey, you're missing this. Something you don't know. But maybe Google it. Yeah, Google it, play around with it. Don't let it be a walking walk though. And you kind of check out what you need. If you do need to borrow one of mine, at any time, feel free. But yeah, you'll be better off once you get it. Maybe you need to know, hey, this is what you're missing. Now with this graph, if you're kind of like, okay, what do I do? Well, did you put some asymptotes in your sketch? Like on your notes, did you draw some dashed lines? Where are they? Did you label them with a number? Are you trying to come up with the amplitude, period, domain, range? Those would be things that you can try to put in your notes. If you're hesitant because you don't want to write the wrong thing, well, at least think about the answer.
before I just tell you, even identifying these 2 points, I would consider to be something also helpful. Again, the 2 points that you can see on each of those branches. Just getting to use your calculator, get to know it, use the trace button, start to notice the way things are spaced out. That's at 90. You can even see there's like a little hash mark there, which was your first 90. Okay, this asymptote, it's at the next 90, so it's at 180. This point right here is at 270, negative 1, 270, negative 1. And then your last asymptote is out here at 360. Don't forget about the asymptote at 0. Just trying to get to know some of the points. Now, again, you say, do I have to memorize this? Don't like stand in front of the mirror and memorize this. Just keep coming back to class and we'll keep working with it. Okay, eventually you start to remember these graphs. All right, amplitude. You might notice that I kind of just said it verbally, that there was no amplitude for tangent. The idea of amplitude has to be a distance from the midline. There is a midline to this graph, but graph or to the bottom. There is no maximum or minimum. So again, the amplitude, it doesn't exist. It doesn't make sense. It doesn't fit into this graph. Honestly, guys, the only graph that has an amplitude is sine, and the one you're going to do for homework tonight, cosine. Sine and cosine have amplitude. I'm telling you, the period is a very significant idea in this whole chapter. Are you starting to think about it? How much x, how much degree to see a cycle? That's one cycle. You say, what do you mean that? That and that is one cycle. In other words, a positive branch and a negative branch. I need both to be able to see the whole graph. How much x is required to see the positive and negative? You can see that the asymptotes are helpful. Okay, but I need 360 degrees to go through a positive and a negative. Now, you'll start to realize that that period connects directly to the period of the sine wave, as they are reciprocals of each other. Okay, but I hope you don't conclude that I thought the period was between the asymptotes. That was true for tangent. The period was between the asymptotes, but you got to just process that the period here is between two sets of asymptotes. Okay, I need a full 360. Did you make the varsity team? You should be on the JV team. The domain is all x such that x is not the asymptotes, but we want to say where the asymptotes are. What's the distance between the asymptotes for this problem? 180, right. It'll always be times k. Where's the first asymptote? Okay, for this problem, we would pick 0. Okay, now if you picked one of these, technically you would get credit, but the best answer is to add 0, which is to add nothing. So we have not equal to 180k. I think this one's a little easier to understand. Okay, because look, if you just plug an integer in for k, 1, 2, 3, 4, you're going to pop out at any one of these asymptotes that are all 180 degrees apart. Okay, careful. Nobody said this number right here is the period. I know it looked like the period over here for tangent, but nobody said that this number is the period. It's the distance between. How about the range? That's kind of a neat, different answer today. Do you think you got it right? Did you think about it? Very good. I gotta squeeze it down here. Negative infinity to negative 1, union 1 to infinity. So you go bottom up to negative 1, or you go 1 up to infinity. You have this space in the middle that's not accounted for. Interesting, the space in the middle is actually the space that the sine wave graphs. They're reciprocals of each other. Now, for your homework, I've kind of purposely left out 3 other graphs. You'll see a homework helper, but all that homework helper is going to do is say, do what we just did right here for cosine, secant, and cotangent. Okay, now treat it like a regular homework, but put it in your notes. Like, that's what I would do. Use pencil in case you got to change something, but I want you to explore 3 of these on your own